In this video, we're going to solve 2005 Form A AP Calculus question number 4. So it says, let f be a function that's continuous on the intervals 0 to 4. The function f is twice differentiable, except at x equals 2. The function f and its derivative have the properties indicated in the table above, where D and E indicates that the derivative of f does not exist at x equals 2. Okay, part A says, for 0 is less than x, which is less than 4, find all values of x which f has a relative extremum. Determine whether f has a relative max or a relative min at each of these values. Justify your answer. Okay, so the first question is pretty easy. It's asking where's there a min or a max. So all you have to do is look at this part. And you have to see where the slope equals 0, which would be here, and also here. Now you also have to look at, or where it's D and E. Now you also have to look at the signs. This is positive, positive, so it's a shelf point. Positive to negative, that's definitely a max. Negative to negative, that's a shelf point, but -3 wouldn't even be a min or max because the slope isn't 0. So when we answer this question, we could write part A, f has a relative max at x equals 2 because f prime changes from positive to negative. Okay, part B says, on the axis provided, sketch the graph of the function that has all the characteristics of f. Use the axes provided in the pink test booklet. Okay, so we got a graph 0, -1. Put a point here. We got a graph 1, 0. Put a point here. We got a graph 2, 2. Put a point right there. Then we got a graph 3, 0. Okay. So now when we graph this, it says the slope is positive, but it's concave down all the way to 0. So we have to draw something concave down. We can't draw it this way because that would be concave up. So we have to draw it like this. That's concave down. Then once it reaches 0, it's still positive slope, but it's concave up. So we have to draw something that's gonna look like this. Okay. Now, once it's between 2 to 3, it has a negative slope, but it's concave down. So we have to make it curve down. That's concave down. Okay, and then the next part is, has a negative slope, but it's concave up to 4. So something like that. Okay, so that's part B. Part C. Let g be a function defined by g of x equals the integral from 1 to x f of t dt on the open interval 0 to 4. For 0 is less than x, which is less than 4, find all values of x at which g has a relative extremum. Determine whether g has a relative max or a relative min at each of these values. Justify your answer. Okay, so let's write that down. G of x equals the integral from 1 to x f of t dt. So in order for it to be a min or max, the derivative of this has to equal 0. Well, what is the derivative of this? The derivative of this would be d dx of this. So that means take the x, plug it in, you're going to get f of x times the derivative of x, which is just 1. So we have to see where f of x equals 0. So where does this equal 0, or where is it undefined? The only point that I'm seeing right now is 1 and also 3. So x equals 1 and x equals 3. So let's look over here. From 1, it's negative to positive. So this has to be a min. A min at x equals 1 because g prime changes from positive, actually it's negative, to positive, and then x equals 3, that's a max, yes, a max, because, I forgot the u, because g prime changes from positive to negative. Okay, the last part of the question, let me move this. So last part of the question says, for the function g defined in part C, find all values of x for 0 is less than x, which is less than 4, at which the graph of g has a point of inflection. Justify your answer. So in order for us to have, let me just copy this down. So g of x equals 1 to x f of t dt. So in order for it to be a point of inflection, we have to take the derivative twice. So we already established it would be the derivative of this f of x, which is now f prime of x, and now we have to look to see where this equals 0. So let's look back. So we're back to the original one, and it has to change signs. So over here, this is positive to positive. That's not a point of inflection. Positive to negative. That definitely is a point of inflection. Negative to negative. That's not a point of inflection. So now we can answer this question. We could say at x equals 2, g double prime of x changes from, what was it, positive to negative? Yep, positive to negative, therefore a point of inflection. I write POI, you should write point of inflection. And I hope this video helped.